I'd like to make you aware of some collaborative tools that I've created in the MATLAB environment for you to have a look at and see how you might use MATLAB in your thermal, fluids, and heat transfer classes. Because hopefully, I assume that you have either taken or are taking ME 2004, which is numerical methods involving the use of the MATLAB software. So let's go ahead and get started. This is a first, hopefully short introductory video regarding how you might consider using MATLAB tools for thermal fluids systems problems. A quick review is what is MATLAB in the first place and why would you want to use it after you've been required to use it? What's in it for me? Or in other words, what's in it for you? And then a quick look at the topics roadmap, and I'm going to try to go live and show you how you might access on my website these collaborative MATLAB tools that I'm offering. So either you have taken or you are taking this course ME 2004 that's called Numerical Methods, but I understand that it strongly involves the use of the MATLAB environment to solve these numerical methods problems. Now, I've only gotten access to MATLAB for about 1 month, have been delighted to sort of teach myself how to use MATLAB and use it as a problem-solving tool. This is just a little screenshot of what comes up for me when I run MATLAB. And I went to the MATLAB website and learned that MATLAB is sort of shorthand for matrix plus lab or laboratory. In other words, it's a matrix laboratory dealing with matrices. But look, I'm learning. I think that's great in working with matrices. Not all mechanical engineering problems involve matrices. And I think you're learning that many of your problems that you're solving with pencil and paper, they might be able to be enhanced with your problem-solving skills in MATLAB. So MATLAB is a problem-solving platform for a wide variety of engineering problems, not just matrix solutions. And also, it is a programming language. So if you have programming experience, that's going to help you in learning how to use MATLAB and also using these various MATLAB tools. So what's in it for me? Why would you want to consider using MATLAB beyond what's required? Well, if you could combine your problem-solving ability, I think you've probably got pretty good problem-solving capabilities now, coupled with sharing tools by others, so some shared supporting tools. If you combine those two ideas, that's going to improve your effectiveness as an engineer. So I just want you to think about that a little bit. Now, if you find a different electronic problem-solving platform that works better for you, then use that platform. It's not like MATLAB is a must-have. I worked through my entire career without using MATLAB at all, without even understanding how it worked or what it did. And so I've been fortunate to have just gotten access to MATLAB here about a month ago and invite you to see what I've learned between then and now. Now, what's in it for me? What's in it for you? If you can improve your effectiveness, then that's going to improve your problem-solving abilities. That's going to make you a better engineer. It will also, if you are more effective, it's going to increase your speed in problem solving. That should make you happy as well, because I'll bet you're finding that problem solving is taking up more and more and more of your time. So if you couple both of those together, you're going to see that's going to improve your performance, both as a student and as a practicing engineer. This is the first intro video, just a little roadmap of what's ahead. I've tried to create another relatively short video regarding problem-solving recipe. How would you solve an engineering problem of just about any type, particularly a thermo problem? And how do you document your work so that you show others what you are doing? That's going to help you in the way people evaluate your test performance, but then in the work world, how other people on your work team will see how you're solving various team problems. The third part is that I've got some videos where I'm introducing how you might consider using some tools I've put out there regarding evaluating the thermodynamic properties of the ideal gas air, of water and steam. In other words, using MATLAB to evaluate thermodynamic properties like you do in the back of the book with steam tables, and the same concept with refrigerant 134A. And then finally, I've got a few videos illustrating how would you solve an engineering problem in MATLAB. These are just example problems that might look like homework problems, might be a little or less difficult than a homework problem, but they are indicative of real world engineering problems that I've been exposed to in the past. Okay, what kind of collaborative tools would you consider using? Are you taking the thermo class and you're finding you're going to the back of the book when you have ideal gas problems and you're trying to find specific heats? When you have the ideal gas air and you're trying to find properties of air like U and H and PR and things like that. I'm offering up a way to evaluate those properties in the MATLAB environment. Similarly, you're probably spending a lot of time going to the back of the book and looking up steam properties, either saturated mixtures or superheated vapor or saturated liquid or saturated vapor or anything in between. Same idea regarding a collaborative tool I'm offering you to be able to identify those properties in the MATLAB environment. And then finally, of course, you're getting more and more questions about refrigerant. I hope you're learning more about refrigeration cycles, and same idea, getting thermodynamic properties for refrigerant 134A. And then the last part, I've prepared some videos for you where I've worked out a problem associated with a steam turbine. How would I start with a MATLAB little starter kit to solve a steam turbine problem? How much power can be developed? An air compressor problem regarding if you know the capacity of the air compressor, how much would it cost me to operate that compressor every day with an electric motor? And then finally, another video on if you have some basic information about a refrigerator, just like you see in your kitchen, how would you as an engineer determine the refrigerator's coefficient of performance? Okay, so this is my cue to go live and show you how can you access some of the MATLAB tools that I've got there out on Jay's Toolbox website that you can download on your own and go to town. You can evaluate them, see if they might help you. If you feel like they would, you possess those files. You can save as, you own those files. Okay, let's see if we can get going on this. See if we can go live. All right, I'm going to my browser, and here we are at Jay's Toolbox website, jaystoolbox.vt.domains. And I've got one page that's got the MATLAB files that I'm offering anyone to have a look and download. So I'm going to scroll down a little bit, go to Toolbox menu, and click on MATLAB. And this is my one page. Let's scroll down and see what we've got. One page. Here is a PowerPoint file that's my full library. I try to keep this up to date on all of the tools that are listed all below. Okay. And so, for example, here we go. Air Properties English. So this is a MATLAB file that I've stored. All you have to do is click download, or you click Air Props English. It just takes you similar download button. And I'm going to go back and get the idea. Simple as that. Then you can possess these files. Okay. Now, one little detail. I have not been able to download or upload these files to my website with the .m file type. So when you download any of these MATLAB files, you're going to need to open them up in Notepad and save as instead of .doc, which is the saved as file type, to .m, which makes it a MATLAB file that MATLAB can read. While I was jabbering on, oh, and let's just scroll down, Air Properties English, Air Properties SI, two different applications for two different unit sets. Here's my air compressor demo, and there it goes on and on and on, some various example problems. Here is refrigerant properties English units, refrigerant properties SI. Let's just more demo problems. And then finally, steam tables for H2O in English and SI. And this would be a little example problem of solving a steam, how much power can you get out of a steam turbine given certain steam conditions? I hope you get the idea. I'm continuing to add more and more example problems and tools to this page. Let's see, I thought of one more thing while we're live. I'm going to click on my MATLAB application. And let's see, let's look at steam table. So we're going to let's go to steam water functions English. So I'm going to click on the steam tables, I hope. There we go. It just, thank goodness. Okay, so I've loaded in steam water functions English. And it's a long, long file because I've created for you and myself a bunch of MATLAB functions that describes the various properties. As I scroll down, what I've got in computer code in MATLAB, I've got demos of how you might look up a bunch of properties. So for example, if I put in English system 212 degrees F, temperature 212 degrees F, shame on me for not putting the units. That's not a good look. I should put units 212 degrees F in a comment. Here's a function call that looks for the pressure at which water boils at 212. And so I've got to move my Zoom menu. If I click run, in the command window, all of my little demo code is printed out, okay? And so here are all the little demo examples. And so it runs, so that this file runs, and this can give you a way to get a bunch of different thermodynamic properties just about with a mouse click. So let's see now, I need to get back to, so that's just sort of the MATLAB demo very quick. Let me see if I can get back to PowerPoint. Okay, there was the go live. And so my suggestion is the sky's the limit with you and MATLAB. Give these, download some of these files, see if they might be able to help you, okay? Leverage those files to support your own work, okay? And then go beyond the files that are offered. In other words, use save as. Think about, how could I use MATLAB and these collaborative tools that are offered to you? How could I use those to leverage existing work and start working on my own independent collaborative work? So that's the idea. And there we go. That's just a little brief intro, trying to give you a little roadmap idea of where I'm trying to go with MATLAB, creating some tools for you, sharing them with you, and hoping that you'll consider using MATLAB as a problem-solving tool in your thermo, fluid mechanics, and heat transfer courses.